Happy 15th birthday.
All right. We're going to talk about quadratics today. Have y'all heard of quadratics before? Quadratic formula, good. I'm glad to hear you've at least heard of that before. We'll use that later on in the chapter. We'll get to that eventually. Today we're going to talk about graphing quadratics. So my question to you is, do you know what a quadratic is, first of all?
It's like 4.
It sounds like it would be 4, doesn't it? It's actually not.
Wow. Very deceiving, isn't it?
It is a little deceiving, it is. A quadratic, what makes a quadratic special is this exponent right here. Ah. That power of 2 on the x makes this a quadratic, okay? So before, you've been graphing lines, right? And the biggest exponent hooked on a variable there is what? If you graph the line 2x minus 3y equals 12. The exponent hooked on the x is 1, okay? We classify these based on their highest exponent. So here we're at a 2. That tells us it's a quadratic. So my second question to you, and by the way, these are variables, and we're going to talk a whole lot more about these in just a minute. It can have, as long as the 2 is there, this can, if this is, that piece does not have to be there necessarily. So for instance, I could have y equals 2x squared plus 3. That is a quadratic.
So like so it always has to be 2 squared.
It's always got to have the x squared on it. Just x squared, that's the parent graph, but that is a quadratic also.
X squared by itself?
It could be x squared by itself. It does not necessarily have to be, if these are missing, for instance, if there is no x term here, then the b is just 0. Okay? I could rewrite this as plus 0x plus 0. Right?
Okay, so it always has to be.
This is your key, this x squared right here, and nothing bigger than that. No bigger exponent than 2. But that's your key there for it being quadratic. All right, y'all okay on that, on how to recognize it being a quadratic?
Did we have to write that second part?
If you want to. It could be negative. Still a quadratic. Yes? All right. Let's talk about what this graph is going to look like, okay? Does anyone know what happens when you graph a quadratic? It does look like that. So she was saying, does it look like that? You know what that is called? A parabola. Good. Somebody got it. It graphs as a parabola, okay? It can go down that way. It can also open up. It can be skinny or wide. That's a terrible parabola. Aw, thanks. Okay, so it can come in many shapes and forms, and we're going to talk about how we can look at this equation that we're given before we even graph it and determine a lot of the characteristics and what it's going to look like. Before we do that, I want to talk about some properties of a parabola. If you are looking at this parabola, wow, again, that's not a great parabola. Oh my goodness. It's a little better. So a parabola has some characteristics, and I want you to kind of look at this and think about some characteristics of the parabola. What do you notice about it that's special?
It has 2 arrows pointing up.
It does have 2, so it's going in the same direction. If it was opening up, then it goes up forever, and if it's opening down, it goes down forever. So you're right, it goes off in the same direction. What else do you notice about it?
Symmetric.
Good job. That was really what I wanted you to get to. It is symmetric. What does symmetric mean? Go back to geometry. Same on both sides, okay? So if I know this point And I know this axis of symmetry is what I'm going to call it. How would you find that same point on the other side?
Go to the same point, except it's going to be like turn around.
What do you call that? A what? Starts with an R. Reflection. It's reflected over the line of symmetry, right? So all those skills you learned in geometry, reflecting points, yay, you get to use them now. All right, so it's definitely symmetric. If you had to pick one point on this parabola that you thought would be a pretty crucial point,
The very middle.
the very middle, why?
Because that's going to be where the origin point is, because it extends out to a specific point.
So it goes, and if you take your pencil along this, and you're on the right train of thought here, and you trace the parabola, I'm going down, 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 down. When I hit this green point right here, what starts happening?
We're going back up.
I'm going up. I'm changing direction at that point. Do you see that? Okay, so a lot of people call this a change of direction point. This is called the vertex, okay? It's where it changes direction. Then let's talk about, those are the properties of the graph itself. Let's talk about if we have this equation and we said it's ax squared plus bx plus c. And by the way, this is what we call standard form. Standard form. If you think back to like whenever you graph lines and you had all the different forms, you had slope intercept, that's everybody's favorite, right? Mx plus b. What's another form you had of a line?
Point slope.
Point slope, that's my favorite. Or what's the other, the third form? It's actually up on our warm-ups up there. You know what that's called? That's actually standard form of a line also, okay? But the point I'm getting at is we can graph in all three of those forms, right? Maybe you manipulate it some, but there's techniques to graph in all three of those forms. So it's the same with parabolas. There's different forms that we can write the equation in. So we're going to focus today on standard form, all right? Before we do, I want to look at these variables, A and B and C, because they tell us some things about the graph before we even graph it. So before we do that, let me make sure that you can identify A, B, and C. If you look at that equation, first of all, is it a quadratic? Yes, it's because it's got the x squared there, no higher, right? So what is A? 1/2. Don't include the x squared because the A is just the coefficient in front, okay? What about B? 0. If it's not there, it's 0, okay? So you might want to make a note, if it's not there, it's 0. What is C? 2. How about this one? Is it a quadratic? Yeah. Sure is. What's A? Careful. -3. That's right. That's okay. That's why we're doing these. What's B? -5. What is C? 0. Good job. So now that you can identify these, let's look at what they do. I feel like I've written this equation 100 times. The first thing I want you to think about is the A out front, okay? If A is positive, we have a happy graph, and our graph is going to open up. That's easy to remember, right?
Yeah.
Yes, good. If A is negative, what do you think happens?
It's gonna look like
down.
It's gonna go down. Very good. It's sad. A is special because A tells us not only if it opens up or down, but it tells us something else also. Have y'all worked any with function transformations before? And what happens when you start shifting parent functions? Okay, we'll talk about that a little more later on. But A also tells us whether the graph is going to be skinny or wide, okay? We're going to say if A is 1, and we're looking at the absolute value of A. What does absolute value mean? Positive. Even if it's negative, we keep it positive. If it's 1, this is what we're going to call an average graph, okay? It's actually called the parent graph if it's just y equals x squared, but when it's 1, that's just an average width, okay? It's going to be going from the vertex, it's going to be going up 1 and over 1 whenever it connects, okay? But here's what happens. As the absolute value of A gets less than 1, so smaller, right? But remember, I'm not negative, so tell me what I'm talking about.
3.5.
Decimals and fractions that are less than 1, but I'm not crossing over into negatives. The smaller it gets, you would think, right? But actually, the smaller it gets,
What is
the wider the graph
what are the
gets.
2 lines with the
Absolute value. So this is the one you really have to remember because it does the opposite. And as it gets bigger, then in turn, what do you think the graph does? Skinnier. Does that make sense to everybody? So the bigger number out front, the bigger absolute value of the number out front, the skinnier the graph is starting to shrink in. All right, so that is A. The other one that I want to talk about is the C on the end. And I'm guessing somebody can tell me what that C on the end might be. I hope anyway. Absolutely. Why? Why is it the Y? How do you know it's the Y-intercept?
That's how it was in the Y.
In Y equals mx plus b, the b on the outside was the Y-intercept, okay? And you said that. And now if you take what we talked about earlier with intercepts, at the Y-intercept, what is 0? At the Y-intercept, what's always 0? X, right? So then it makes this hopefully makes a little more sense to you, because if I put a 0 here, that term's canceling out and I get y equals b. That's why that's the intercept. Well, if you look at this equation, if you were to put a 0 here and a 0 here, what are you left with? The C. So the C is always your y-intercept. Does that make sense? Why? You plug a 0 in for the x's, you're left with the constant on the end, and that's your y-intercept. I feel like some of y'all are looking at me like that. It made absolutely no sense. Y'all with me? Okay. All right, so let's analyze a couple and see what happens. Let's say I have negative 1/2 x squared plus 2x minus 3. Is that parabola going to open up or down?
Down.
Why?
Because it's negative x. So
That right there tells you it's going to open down. We all agree with that? Is the graph going to be skinny or wide or average?
wide.
It's going to widen up from an average one, right? Because this is, I'm going to just put wider than average.
And the average is 0.
Average is 1. So if it was just x squared in front.
What half is 100?
Right, half is smaller than 1. So if you go back and look at your chart, the smaller that it gets, the wider the graph gets. It does the opposite of what you'd think it would do. All right, one other thing you can tell me from this. What is that? Y-intercept. Where does it cross the y-axis? Does it make sense to you that this is only going to have one y-intercept, even though it's a little bit different shape? Does everyone understand that? How many x-intercepts do you think it could have? 2, or none, or how could it have 1 x-intercept?
You can combine the x's.
If you like going down the y-intercept,
You're right.
Zero.
Let's think about a coordinate plane. How many x-intercepts? 2. How many y-intercepts? 1. This is a little tricky. How many x-intercepts?
0.
0. It's going up forever. It never goes below here, right? How many y-intercepts? 1. Do you see why? This is inching outwards. If I went on forever and ever, it's eventually going to cross the y-axis. Again, 1 y-intercept, yes? Now, how many x-intercepts? 1. Do you see why? What's happening? What's on the line? The vertex. Very good, very good. The vertex sits on the x-axis will give us 1 x-intercept. How many y-intercepts? 1. So you're always going to have how many y-intercepts for a parabola? 1. Good job. Everybody understand?
We'll always will have 1 y.
Yes. But you could have none, you could have, 0, 1, or 2 x-intercepts. All right, y'all ready to graph?
You want us to get graph paper out?
That would be lovely if you have it. It'll probably help you keep track of all your stuff. All right. I'm going to do you a little step sheet here because I find it kind of helpful if you can go back and look if there's ever a general step formula that we can go by. So let's see. Let's do steps and an example to run along with it. And I'm going to have to keep flipping to the next page to graph. I'm going to pause the little crooked there. All right. So I'm going to give you general steps if I'm just in standard form. And we will run an example along the other side. Let's say
Could we put this on graph paper now?
graph paper would be great. (2x squared plus x minus 1). Now while y'all are getting set up and before we even start to graph it, tell me what you know about this graph without graphing it.
It's going to be positive.
It's going to be positive, which means it's going to be what? Up. It's going to open up. That's right. Absolutely. It's going to be a happy graph. What else do you know?
It's going to be skinny.
Skinny. Why?
Because it's bigger than 2.
It's bigger than 1. It's going to be skinnier than an average graph. What else do you know?
The y-intercept is negative 1.
Y-intercept is negative 1. Yes?
How was it? Oh.
One other thing, and the reason that we did number 2 as our warm-up, think back to when you were graphing lines, and if you wanted to find any point on the graph, let's say you just wanted to pick an x to find the coordinates of, what would you do? How would you find the other half of that point? Plug it in, right? All right, so remember that concept because that's going to come up again, and I'll show you in just a minute. All right, so the first thing we're going to do, what did I tell you was probably the most important part of the parabola?
A.
The vertex, somebody said it, the vertex, right? That point where it changes direction, that tells us everything, because what goes through that point, if you look back at that picture? The what? The line of symmetry, or the axis of symmetry, okay? So that's what divides it in half. So the first thing I'm going to do is I'm going to find and plot my vertex. Is everybody okay before we get into this? Do y'all need a stretch break? Are we back? Oh, we're back. Okay. So I said find and plot the vertex, so you need to know how to find the vertex, right?
Yeah.
Right. All right. So I'm going to tell you a little formula to help you find the x part of the vertex. Now I have negative b, but I want you to think of it not so much as negative b, but opposite b. Because if b is already negative, I don't want you to get confused thinking negative b, okay? So opposite b divided by 2 times a. You think you can remember that? That's T90, right? Let's come over here to our example side, and let's do that and make sure you understand. Well, before you start, what is a? 2. What is b?
0. No.
Careful. 1. This time it is there. It's just that imaginary 1 in front. What is C? Negative 1. Right? All right. So x equals. So I want the opposite of b. So that's what? Negative 1. Divided by 2 times, what is a? 2. Oh, what a terrible one to say. I'm sorry, y'all.
I'm confused.
Okay. Here's the formula. So what I'm doing, I'm running the steps right here along with the example. So step 1 is this, and now I'm showing you how to do it with the example as we go. So the formula is opposite b over 2a. So here, a is 2, b is 1, and c is negative 1. So opposite b and 2 and a. Follow me?
What is he?
Why is B 1 then and not negative 1?
Yeah.
Is the opposite of
The formula is the opposite of b, but b is actually positive 1. So if I do opposite, then I'm going to make it negative here.
It's B.
Correct. You with me?
Wait. Oh, now I get it.
You with me? Okay. No? Somebody say no? Okay. So this is negative 1/4. Now understand what this tells me, okay? This tells me that somewhere, if I come over here, somewhere at negative 1/4, and I'm going to say that's about right here, right? Somewhere on this line sits my vertex. Do you agree with that?
Yes.
So I have also found what? By just finding the x half of my vertex. My line of symmetry.
Oh, yeah.
So here, this is also your, I'm going to call it your axis of symmetry. We'll use some good vocabulary here. I'm out of room. There we go. Now, think about this with me for a minute. If I've got the x part of my vertex, right? And I want to know where on that line sits my vertex, what do I need to do? In other words, I want the coordinates of my vertex so I can plot it. Right now, I have half of it. How do I find the other half? Plug it in. You have an equation, right? The other half is y. You have an equation that tells you what y equals if you have x. So plug it in. So y equals. It is. Is it the same problem we did in the war? It's very close, yeah. All right, 2 times negative 1/4 squared plus negative 1/4 minus 1. Keep it exact. What's wrong? Am I going too fast? You with me? I'm just taking this and plugging it in for the x's here. The first one takes a long time because I'm explaining as we go, but once we get past the first one, they'll move a lot quicker for you. We'll do several examples. All right. Remember, I've got to go order of operations. Parentheses, exponents come first. Don't multiply these two first because exponents come first. What is negative 1/4 squared? 1/16. Minus 1/4 minus 1. 2 times 1/16 is what? 2/16, which is 1/8. Running out of room again. 1/8 minus 1/4 minus 1 is anybody. Let's change them all to denominators of 8. Oh my goodness, fractions are our friends. Negative 9/8.
Where'd you get 2/8?
I changed this 1/4 with a denominator of 8 so I could combine them. I'll give y'all a second to catch up with me. All right, so the coordinates of my vertex are negative 1/4 and negative 9/8, right? Are y'all tracking with me? That's a lot of work for a vertex. But we can plot that. Negative 9/8 is a little past 1. So I'm going to put my point here. And there's my vertex. I would get in the habit until you're used to graphing them of labeling them with a V or vertex. Otherwise, you start to get your points mixed up. All right. So there is 1 point. Man, why is that there? Y'all stay with me. Step 2. We need another point. Okay? Now I want you to think about what I told you earlier, where if you're graphing a line or you're graphing anything and you need a point, how you find that point, okay? So we need another point. You should, based on this, when it's in standard form, it's a little easier. What's an easy point if you just look at that equation that you know right off the bat is on that graph? 0, negative 1. The y-intercept is always going to be there. That is easy peasy, right? So you can use that as your easy point by all means. Now, if that number on the end happened to be 25 and it was hard to graph, you might not want to use that point. Then what could you do?
Where did you get 0,
Negative 1 is the y-intercept here on the end. So it's an easy point to graph. What might you do, and we'll do one in a minute where it's not so easy to graph the y-intercept, but if that was like a 25 on the end, what could you do to find another point?
Yeah, what could you?
What could you do? Some of you are fixing to say it, but you're scared it's going to be wrong. Just pick one to put in. There's no...
You can make a random.
Yeah. But the bigger you get, the further away from the vertex you get, if you think about the way a parabola does, the further away you get from the vertex, it's going to shoot up really fast or shoot down really fast. So you want to stay close to the vertex when you pick your x.
Yeah.
All right, let's plot our other point. Let's plot our 0, negative 1. I'm back on my graph. Are y'all plotting with me? There we go. Now look at what I have. Okay?
And then you're going to mimic it on the other side.
Absolutely. That's the only thing I have. I love this step. This last step, and I'm out of room here. I call reflect and connect. Because I'm going to reflect it over the axis of symmetry and I'm going to shape my parabola from those 3 points. That's all I need is those 3 points. So if I reflect over this line, these are easy reflections because if you went over a quarter, you just go over another quarter this way. It keeps doing those little. Oof. And connect it. Make sure you're not, that you kind of round out your vertex here. It's not a sharp point. And there's my parabola. Sure. Yours is big? We'll do a big one. What would I need to do to make it a big one? Have a small A. Absolutely. So we'll do a small A in a minute. What's my time? 101.
The 0, -1, did y'all just pick like a random point?
That's the y-intercept that's hooked on the end. That -1 is the C. So we use that. So whatever was on the end, like for number 2 in our warm-up, 0, -5 would have worked. I mean, what the heck are you talking about? Y'all ready? Oh no. Let's do that. All right. Several of you are a little confused on that one, so let's open it up a little bit. Is it going to be up or down? Now is it going to be up or down? Down. We just did an up one, so let's do a down one. Is it going to be average, skinnier than average, or wider than average? Wider than average, right? Because it's less than 1. So maybe this will be a little easier for us to see some of the detail on it. What do I need to find first if I'm going to graph this? The vertex, right? All right, so Shamik says the vertex, so let's find the vertex.
Negative b over 2a.
But instead of negative, I'm going to think opposite. So what is b in this equation?
0.
Oh, 0.
And or opposite.
So it really doesn't matter what's in the bottom, right? Because 0 divided by whatever is 0. As long as a is not 0, and a is never going to be 0, I wouldn't have a quadratic. What's wrong? You can ask.
No, I figured it out.
Okay. All right, so x is 0, yes? What is y? 15. If I plug 0 in, oh, look, this is going to be a special scenario. What are the coordinates of my vertex? 0, 15. So my vertex is doubling as a what? Y-intercept also, right? Not y-intercept, yeah, y-intercept. You see that? All right. Let's plot that when you get your graph paper. Did somebody say wait? You need me to go back a second? Okay. That's okay. Do you see where I got the x coordinates and then how I mean the x coordinate and then plugged it back in to get the y value? All right, so I plugged into the formula. I said here a is -1/2, b is missing, so it's 0, and c is 15. So the opposite of b, well, the opposite of 0 is still 0, and 0 divided by 2 times 1/2 is still 0. Doesn't matter what's on the bottom. If you divide 0 by anything other than itself, it's going to be 0. Y'all tracking with me now?
Then you put a 0 back into the regular formula.
Then I put it back in the original formula to find the y value. Okay? So now I'm going to plot that I know I gotta go up to 15, so I'm gonna try to give myself plenty of room. All right, 0, 15, right guys? 2, 4, 6, 8, 10, 12, 14. I'm going by 2s, by the way. Mark it with a V.
2, 4, 6, 8, 10, 12.
You're going by how many?
I went by 2s, yes.
I'm supposed to do that.
Look at there.
Oh, you gotta put the V and all that by too?
You should, because if you don't, what's going to happen is you'll mistake, whenever you put that second point on there, you'll forget which one's the vertex and which one's the point. You'll reflect the wrong one and have the wrong parabola. All right, I just dashed my line there because through the vertex goes my what?
Symmetry.
Axis of symmetry. That is correct. So if you draw your axis of symmetry, maybe you don't have to mark it with a vertex. I mean, you can just, because then you'll know that's the middle.
But you ain't got no color code, you can't do that.
Why?
I'm not around the symmetry.
Oh, because you've already drawn the axis on there. Yeah. You want to borrow my pink pen? Okay.
I just put a V by.
Okay, there you go. I need another point, yes?
15.
Oh, but that's a problem this time, right? That I've already used that y-intercept. I can't use it again for another point. I need a different point. So this is where I was telling you that you'll pick an easy point, okay? Stick close to the vertex. Look at my vertex. My vertex is 0, 15, so I want to stick really close to this 0. What is close to that 0 that would be easy to plug in? 1. 1. That's what I would do. If I plug in 1, negative 1/2 times 1 squared plus 15. Remember your order of operations and always square this first. What's negative 1/2 plus 15? 14 and a half. So what are the coordinates of that point? Close.
Where did you get excellence 1 from?
I chose that because before I used the number on the end, right? But this time I couldn't use that number on the end as an additional point because it's already my vertex. So I had to use another point. So I just stayed real close to 0 and picked 1. Maybe you picked 2. That's okay. Maybe you picked 4.
You had to pick.
Any number, basically.
You just need one other point to pick. Yeah.
Pick any number.
You can pick any number. The further away you move from your vertex, the larger the number's going to get. Yeah.
So why on the last one we used y? We changed y, but on this one we changed it.
What you mean changed it? Which one?
Right, on the last one we did 0, -1, and on this one we picked 1.
Well, the other one, the vertex didn't sit on the y-intercept. You see, this time, this is my vertex, so I can't use that as my easy point to plot. I'm going to actually have to do the math with it. See the difference, if I go back, on this one, 0, -1, my vertex was -1/4, -9/8. So I could use the y-intercept as a second point on my graph. But here, my vertex is 0, 15, so I can't use that as an easy point. I have to pick another one. You've got to have 3 separate points on your graph. Your vertex, any point, and then the reflection of that any point. Does that make sense? You sure? Okay.
You can use calculators for this too?
Not to graph.
I'm talking about like
This is-
when you plug in stuff, I don't know what it is. I mean, what do they know 1/2 plus 15 was?
You don't know 1/2
No,
plus
I do.
15
I'm
is?
just saying in general. Like, I didn't do something.
He's saying there's
Yes,
like big
yes, yes, yes. Remember, you got to show me all your work, though. All right, let's plot this point, 1, 14.5. Remember, I'm going by 2s, right? So, let's see, this is 14, so just a smidge past. I don't know why this thing keeps drawing a circle around my... All right. Oh. So there it is. Can you see it a little bit?
Yes.
Now what?
Reflect, man.
Reflect it. So if I go over one to here, to the line of reflection or the axis of symmetry, I'm sorry, I'm going to go over one more here. I went over too far. And now, I'm going to just connect it. Does that make sense?
Yeah.
Yes, ma'am.
How do you get like the second point? One that you're supposed to reflect?
You pick any point you want. If there is an easy point, as in like the y-intercept, you can use that. In this case, we couldn't because of the vertex, but you can pick anything. What I generally do is I look at my vertex, and let's say if my vertex was 2, 8, then whenever I get to this step, I might pick x equals 3. Just pick one that's close to that vertex.
Oh, okay.
That's all you have to do, yeah. Other questions about that? One more, let's do another one. Some of you are still looking kind of...
Yeah, it's very hard.
Okay.
I got it, Miss McGee.
You got it?
I think I do.
That's good, I hope you do.
I ain't got distractions. I ain't away from this thing.
Let's do another one like that. Up or down? Down. Average, skinnier than average, wider than average? Wider than average. Y-intercept.
-3.
Everybody with me?
Yeah.
What are we going to find first?
Oh, vertex.
The x of the vertex. How do I find the x part of the vertex?
Do the little formula.
Opposite b
But the B is 0.
2 and
over 2 times a.
0.
I still don't understand why it's 2 times A.
That's the formula. That's just the formula. All right. Tell me before we plug and chug, what is A?
1/5. -1/5.
Negative 1/5. What is B?
0.
0. What is C?
-3.
Negative 3. Guys, stay focused. All right. I'm going to plug in here. Again, look what happens.
0.
It's going to be 0 because B is 0. Yes?
Because there is no B.
Because there is no B. Correct. I need the y portion of my vertex now. What is the y part? You got to plug in 0 to C. So when you plug in 0, what do you get? -3. What are the coordinates, guys? What are the coordinates of my vertex?
0, -3.
0, -3. Yes?
Yeah, that's easy.
All right. Let's see. I'm going to come here and go ahead and do my graph. Zero, -3, right? Oh, did we say up or down?
Down.
All right. Down, down, babe.
Then we can't use the y-intercept and that's another point.
That's right, Shamik. Why?
So we already got it.
We've already got it. We can't use the y-intercept as our easy point. We're actually going to have to calculate another point because the vertex is our y-intercept. So, looking at this, and this is where a lot of you got stumped last time. When we look for our second point, guys. Thank you. What should we pick?
Something that's very close to 0.
Something that's very close to 0 because that's going to make my life a lot easier. Shamik says 1.
Why is 0?
Well, I got to plug in.
Oh.
All right, 1 squared
What
is,
is the exclamation
One.
point you're doing?
that's a, the pen keeps dragging, that's just a 1. All right, -1/5 minus 3. And even though I dislike decimals, I'm going to make this a decimal so it's a little easier for you to see as we graph -3.2. Now, if you want to look at the equation, and I don't do this too much, especially when I'm introducing it, because then you really don't understand where my x's are coming from. But when you start to understand how this is plugging back in the equation and you've got a fraction in front, maybe if you put something here that would work out nicely, like you plugged in a 5, and 5 squared is 25. 25 divided by 5 is 5, and you get a -5 there. You get a nice whole number instead of the fractions and decimals, but we can still work with a 3.2.
All right, hang on.
1, 1, 2, 3. Down a little bit. Remember, this is my what? Axis of symmetry. So what do I do with this little blue point? Reflect it. Connect it. Yes or no?
Yes.
We feel better about it?
Yes.
Okay.